Okay, welcome to this video on Advent of Code 2021, Problem 1 in Clojure and Python. I'm going to show you how to solve this in Clojure because that's my favorite programming language. I know you don't know how to program in Clojure, but it's just to give you a little taste of a different language, something that's much more powerful than Python, really. And then, of course, we'll look at Python because it's what you're more familiar with. So here's the website, adventofcode.com, and we're on the first problem here. So let's just get a little look at it. So you're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside a submarine. The elves keep ready for situations like this. It's covered in Christmas lights because of course it is. And it even has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. So every year in Advent of Code, we're trying to get 50 stars, and we can get 2 stars a day by solving 2 programming problems a day. You have to solve the first one in order to get access to the second one. Okay, so on with the show. So as a submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby sea floor. On a small screen, the sonar sweep report, which is your puzzle input, appears. Each line is a measurement of the sea floor depth as the sweep looks further and further away from the submarine. For example, we could have an input like this. This is a very small input. Our real input is much larger. So these are depths. The report indicates that scanning outward from the submarine, the sonar sweep found depths of 199, 200, 208, and so on. The first order of business is to quickly figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. There's no measurement before the first measurement. In the example above, the changes are as follows. So you can see 199 to 200 is an increase, and then 208, another increase, and 210, another increase. Back to 200, that's not an increase, up to 207. So you can see that, and there are 7 measurements that are larger than the previous measurement. And how many measurements do we have that are larger than the previous measurement? Okay, so I've already answered it. The answer is 1482. Your puzzle input can be different. And so if I get my puzzle input, then it's here, right? So quite long, right? So what I'm going to do is now set up a Clojure project. So don't look at this. This is a current project I'm working on. I'm going to create a new project. Here we go. New project. Yep. Call it AOC 2021. In a new window. And here we go. So just a word. So we've used Python before, which is a pretty lightweight language. You know, you can just have a text editor and run a command called Python to run your program, and that's all you have to do. Clojure is a more heavyweight language, unfortunately. I do prefer lightweight languages, but I thought of an analogy. Python is like a garden hose that you can just very flexible, do what you like with it. You know, walk over here and water the garden, walk over there and wash the car, etc. Clojure is more like a water cannon, much more powerful, but it needs infrastructure. You can't just pick up a water cannon and use it, right? And it's too heavy and it's too forceful, so you'll get blown away by holding the water cannon. So it needs to be in a heavy rig that gets moved around. That's all a bit unattractive, but once you get started with Clojure, it's actually very delicate. So open source here, right? So we've got NS for namespace, adventofcode 2021.core. There's a function here that's just, I can get rid of that. And I'm going to say, right, so I'll define a function for problems 0, 1 that can take x's, right? That's the numbers that gets input, and like we'll just give an answer of 1 for the moment. Obviously, that's not the answer, but I'll come back to that. We need to store the data somewhere, and I'm going to store it in a separate file. So I'm going to right-click on here and say New Clojure namespace, and I'll call this data, and I'll call it input. It's called the puzzle input. There we go. So it's created a new file here and a new namespace. And I will def, so this is defn makes a function. Def just creates a value. We call this P01 data. And I'm going to now copy all of this and paste it here. Okay, so, and what I can do is select that and just make it one line. Okay, so that's one very long line. And for testing purposes, I have P01 test and go back here and copy the test data. And we know that when we run this, then the answer should be 7. Okay, so it's just good to have data where you know what the answer is, so then you see if things seem to work. So by putting my data in a different file, it means that this file won't get cluttered with things. All right. Now just a couple more things. Well, I'm going to create this just every time I do a Clojure project. I have a file called gslib, gs being me, and lib, that's my library of just code that I really want to have handy. So I'm going to copy it from another project and paste it here. And I'll just change this. There we go. So yeah, this just has a bunch of code that either stuff that I wish was in Clojure or things that are just very useful to me, including a few things that I created that are useful to me. Okay, so inside my core, where I'm actually solving the problems, I need access to these other things. So I can say require AOC gslib and say refer all. That means that anything that's in here, right, like the bool function, right, anything that's in here, I can now call directly in here, right? I'll demonstrate that in a bit. And also AOC, I need the input. Now I don't want to refer that. I'm going to say as input, just give it an abbreviated thing. All right, so P01. Oh, yeah. And now, next very important thing is I'm going to run a REPL. Now you're used to seeing a REPL for Python. Well, this is a REPL for Clojure, which is much more powerful. I'll just move this over a bit. Okay, let's just get a little taste for this. So I'm running in a REPL here. So if I say I want to know 3 plus 5, then that shows me what gets evaluated and the answer 8. Right, that's no big deal. I'm going to go over here and load the whole file, and then if I go here, then I should be able to run the P01 function, and I need to give it some input, and it gives me the answer 1. See, I've just got the answer 1 here. Now, the thing is, if I change this, let's say, to 5, then with a certain keyboard thing, I can just reevaluate that function. And then down here, I can go P01, 1, 2, 3, and I can evaluate that, and I get the answer 5. So I don't actually have to type in over here at all. I can if I want to, but I can just type in here and send an individual thing from here over to the REPL. It's very nice. Whereas when we're in Python, when we want to run something in the REPL, then we have to run the whole file. And that's very annoying compared to this. Okay, so let's get on with it. So I'm going to do I won't put this in yet. So in my GSlib is something called EG. And what EG means for example. So I'm giving an example of what P01 does. And if I use input P01 test, then that is supposed to give an answer of 7. And that's what this is saying, right? It's saying that if you run this function, P01, using that test data, then that produces a result of 7. Okay, so if I run this, then it says fail, right? The expected was that it would be 7, and the actual, well, it says that it was 5. This output could be a bit better, but it's telling us that 5 doesn't equal 7, basically. So we get a false, all right? So obviously, one way to fix that would be, to change that to 7, and then when I run for the example, then I get a true, right? And there's no fail message. Anyway, that's obviously a cop-out. Okay, let's get into the nuts and bolts of it. So what I need to do is take, well, remind myself of the problem now. Oh yeah, so what I want to do is look at pairs of these. I want to look at 199 and 200 together, and then 200 and 208 together, and then 210 and 200 together, and so on. So basically, I want to look at pairs in a sliding window formation. Now, Clojure, here's a Clojure cheat sheet. You can see I'm scrolling fast. There are a lot of functions that you can call in Clojure. And they're organized here, and you're not going to learn much about Clojure by looking at this cheat sheet. You need to understand it first, but the cheat sheet's good for referring to stuff. One of the key things in Clojure is called sequences, right? And what I want, I've got a sequence of things, and I want a sequence of like pairs. And the thing that I want is called partition. I want to partition this into I want to partition the collection into, into smaller parts, right? So here are some examples. Range 20 gives you 0 to 19, right? And if you partition it into groups of 4, you can see the effect there. 0, 1, 2, 3 is in the first group, and then 4, 5, 6, 7, and so on. Now, if you can give it a step, so it changes the starting point for each partition. So partition 4, 6, the size is 4, but then it doesn't, it starts the next one at 6, and then it starts the next one at 12, right? So what I want to do is I want to say, well, let's just say partition groups of 2 x's, right? Now, if I run this, all I've done is define a function, and I'm not going to call the example. I'm going to call the P01 input. Okay? And you can see that it's giving me 199 and 200, but then it's moving on. It's not giving me 200 and 208, right? So if I put a 1 in here, then it means only move along 1 each time. Okay, and there we go. I get 199, 200, 200, 208, 208, 210, and so on. And so now what I want to do, I've got a list of these things, right? a list of pairs, and I want to filter out the ones that are increasing. So I can do that by filter, and I'm going to give a function. Right now, the function is two things. So I'm putting that. I'll call the two things A and B, and I just want to know if A is less than B. So if I define that and now run it, okay, then I've got a smaller list now, and you can see that in all of these cases, the pair is increasing, right? And that's what the problem wants. And now I just need to know how many of those there are. Right, so reload that, okay, and that's given me 7, right? And if I run this example, then of course I get true. And what I really want, so I suppose I'll undo that. I can load on the real data, and I get the answer 1,482, right? And so then I go back to the website, and I put it in here, but I can't show you that because I've already done it. You're right, and so now, so there we go. Right. So there's a lot about this that you don't understand, but I just hope the high level details you do understand. We're creating a partition of group size 2, and moving along by 1 each time from our list, and then we're filtering out the ones where if you call each pair A and B, then you want A to be less than B. So we're filtering those, and then we're just counting. So it's a very direct solution. The solution is really saying exactly what we want, right? And when I do this in Python later, it won't be nearly as elegant. All right, and so now let's read problem 2. So part 2, considering every single measurement isn't as useful as you expected. There's just too much noise in the data. Instead, consider sums of a 3-measurement sliding window. Again, considering the above example. Now, this is a bit confusing to look at, but we want to basically first, I can show you up here. We want to first consider those 3, right, and add them together, and then consider these 3 and add them together, and then consider these 3, and so on. So that's called a sliding window of size 3. So this is saying the AAA is like the first measurement, the BBB is the second measurement, and so on. All right, and so we need to calculate the sums of these, and then once again we want to know how many times did the sum increase, and this time there are 5 out of them. Okay, so to do this, I'll define problem 01. Oh, I meant to call it 01A before. Right, so I'll just reevaluate that bit. Okay, so when I say reevaluate, it's literally reevaluating those 4 lines, nothing else in the file. So it's very nimble. So like I said, this is all a bit heavyweight to set up, but it's very nimble once you're actually using it, and that's wonderful. Okay, so to solve problem 1b, then well, if we take partition, we want a size 3 moving up by 1 of x's, right? And then we want the sum for each of these. Okay, so once again, I'll P01B input P01 test. Okay, and I just realized I better change the name of that. I'm just going to reload the whole file just because I've made a few changes. There we go, reloaded the whole file. Okay, so if I run this, right, you can see, I'll just move this over a bit so we can kind of see everything at once. Right, so I'm getting a sliding window of size 3, and now I want to get the sum of all of those, right? So I've got a list of triples, and now I want to get a list of sums. Well, I need the function map for that, and I want to map the sum over those, right? Now the problem is sum doesn't exist, right? And so I can define a function sum, but I want to do that elsewhere. I'm going to just show you, because surely I'm going to need to calculate the sum of things again in Advent of Code. So I'm going to create another namespace called util, which is short for utility functions. Okay, now obviously I've got a library of utility stuff here, but this is stuff that I want available to me in any project, whereas utility is like stuff that's useful in this particular project. So if I can define the sum of some numbers, then I'm not going to go into the detail here, but that's all I need to define a sum. Okay, and so I'll load this whole file. I'll go back here, and I need to load this, and I'll give it the abbreviation util. I might just demonstrate a couple of things for you, actually. First of all, I don't, right? I'll be able to call this now, right? That loaded okay. And now this, and you can see it's got the sums of all of the things, right? So, once again, without that, you get all of the triples, and then this is now giving me all of the sums, right? So that's fully quoting like the namespace and where the function is and the name of the function. Well, that's a bit annoying, right? So what if, so that's why we do, as util, right? And so that allows me to abbreviate this. Okay, so just no such namespace util. I'll just reload the whole file just to let that take effect. Okay, and then this works again. Or if I really didn't want to even type util, I could say refer sum, meaning that that definition gets referred to this namespace, and reload the file, and then map sum, and then okay, that works. All right, but I'm going to keep it like I had before. Okay, the benefit of that is that you can see in the code where the thing comes from. Okay, so I've got the sums, and now I want to find out how many of these are increasing. Well, the nice thing is I already have a function that does that, and that's P01A. Okay, and so there we go, 5. Right, so I get to reuse what I had before. And in fact, I can even put a comment in here. Right, P01A, all this function's really doing is count the number of items in the collection that are larger than the item before. And so that's not just solving problem 1A, that's actually a useful thing, okay? And I get to use it again here, right? And so this one, let's put a document in here. So consider consider sums of successive triplets and count those that are larger than the one before. CP01A. Okay, so I'm just putting a little bit of documentation in there. And so what I'm going to do now, I now know that, right, so that this one here calculates 5 as it should. Well, I'm going to make that an example, right? So I can wrap this in brackets and put e.g. and then that's 5. I'll just check that. Yes, true. Now, I'm just going to clear the screen here. Which one? That clears the screen. Right, so if I reload the file, then you can see that it's actually executed both of these examples, right? Now, I actually don't want that, right? That's just because they happen to be at the top level. I don't really want them to be executed every time I load the file. The reason for that is it's quite possible I'll end up with something later on that takes a long time. So what I'm going to do is wrap this in a comment, and likewise, okay, wrap this in a comment. And what that means is, so now when I load it, you can see here I load it again, they didn't get executed, but if I want to execute it, then I just go Command-Shift-P and this bit gets executed, right? So that's just really good that I can now be selective about that. Okay, I'll get rid of that. And now I calculate P01B input and P01 data, that's the large one, and I run that and it gives me 1,518, which I typed in here. Okay, and when I typed that in, it said, told me that I was correct, and it said both parts of this puzzle are complete. They provide 2 gold stars. Okay, so at this point, you should return to your Advent calendar and try another puzzle. Well, there are 16 and a half hours until the second puzzle comes out. And so it's about 4 p.m. Well, it is 4 p.m. Sydney time every day, which is pretty convenient, actually. And this picture will develop over time, right? If I look at leaderboard, okay, so here's the worldwide leaderboard of, like, obviously there are thousands of people doing this, right? So I've got no hope of being on the leaderboard because you've got to be the quickest. But if I look at a private leaderboard, then right, you can see that Angini got in before I did here, right? And Amy and Mr. Galani are haven't attempted anything yet. And if you want to join the leaderboard, then you just ask me and I'll give you the code. Okay, so that is done in Clojure, right? And so I'll keep doing these, and I think I'll put this in here. What's it? 1518, I think. Yeah, it's over there, 1518. So, it serves as an example, right? And this one, well, if I run the example, it'll tell me, no, it's meant to be 1482, so I'll just change this to 1482. Okay, and reload the whole thing, and okay. You can see that when I've got 2 examples in here, and it gives me true, right, telling me that they're both true. So anyway, if I make future videos, then there'll be a lot less explanation about how I structure my code. I just thought that you might find it interesting. Okay, it's very different from Python. All right, speaking of which, let's get into some Python. So I've created a directory called AOC2021, and I'm just going to create a file. All right, so I'm in a Python file now, and it's going to see. So I need to, so here's a list in Python. Right, in Clojure, I didn't need to put commas in, right? I didn't make a point of that before, but here's our input. You can see that it's just, right? You don't need to put commas in. You can if you want, right? That's just a nice, like, this is legitimate, and so is that, okay? Clojure ignores any commas that you put anywhere. So you can put them in if you want to make something easier to read, if you think it's going to be easier to read, but you don't have to put them in. And that's just really useful. And data 01 equals that. Okay, so I don't want to add a comma one at a time, but what I can do is I can append a comma to the end of every list there, every item there. And I'll change this one there, select the paragraph and join everything. Okay, so I'm going to turn wrapping off. So there we go. It's a long line. So I've got test one and data one. And now I'm going to say def problem 01A. And so that takes a list. Right, so I'm in Python. So how am I going to do? I want to check to see if how many items are greater than the one before. All right, so I'm going to set count equals 0, and then I'm going to say I'm going to say n is the length of, I want to know how many I'm dealing with. And then I'm going to say for I in range. Now I want to start at 1 and stop just short of n, right? I'm going to say if x's I is greater than x's I minus 1, so that's a comparison, like if there was an increase between two consecutive elements, then I'm going to add 1 to count. And then when I get to the end of the loop, I can just return count. Okay, so I mean, that's nice, simple Python code, but it's just so much, I don't know, it's so much more low level than the Clojure code. You know, I have to set a variable called count, and I have to keep updating it. I have to use indices, right? I just didn't have to do any of that in the Clojure one. So why am I starting at index 1 and not index 0? Well, because I need to make a comparison between this and the one before it. So if I started at index 0, I'd be comparing index 0 and index -1, and that wouldn't be very good. Okay, so I'm going to say assert, you might not have seen this before, assert that P01A of test 01 is equal to, should be 7, right? And now I'm going to run this whole file. So Python 3 and just run the file. And no news is good news, right? It's given me no output. If I change this to like an 8 and ran it, then it would give me an assertion error because that assertion was wrong. Okay, so that assertion Okay, and now I can say print P01A of data 01, and when I run the whole file, okay, I get 1,482, just like I did before. All right, and so I'll turn that into another assertion. Okay, it's just like a bit of executable documentation. Now def P01B, so I've got a list there. Well, once again, I'm like, I need to make some sliding windows, right? And so there is an elegant way that I could do this in Python, but not easily, and I'd have to actually do it myself. Like Python doesn't, as far as I'm aware, Python doesn't have anything built in that makes it easy for me to get those sliding windows. So what am I going to do? Well, I think I'll just do this like as if the first problem didn't exist. So I've got count is 0, and now what am I going to do? I'm going to say, well, I need to once again need to know length. Right. So for I in range, now I'm going to start at index 2 this time and go up to index like just before index n. And I'm going to say I could say triplet sum equals. I need to start at 3. Triplet sum 1 equals x's. Well, Python has a sum thing. I can say x's I. Actually, this might just confuse you. Right, x's I plus x's I minus 1 plus x's I minus 2, right? And I'm going to call that triplet sum 2, and triplet sum 1 be I minus 1, minus 2, and minus 3. Okay, and I'm going to line these up because I like doing that. And so, okay, so it's triplet sum. So triplet sum 1 and triplet sum 2, and now I can compare them, right? So if I can say if triplet sum 2 is greater than triplet sum 1, then increase our count, right? Get to the end and return the count. Okay, so I'm calling function b now, and this answer should, this answer should be 5, and this one I'm not running yet. So rerun the file. Okay, name x is not defined. Where's, I should have looked at, what line number that was. Line 19, I can't see an x. Oh, there we go. Right. That should be an I, and so should that. Okay, run the whole file. Okay, I've got an assertion error, and that's because that should be commented out. Okay, so no assertion error, right? So I'm getting the correct value for test data, right? There are 5 triplet sums that are bigger than the one before it. This is awful code, by the way, right? So I can do better, but I guess my point is because Python doesn't as far as I know, come with the nice tools that say, oh, you want to look at, a sliding window, right? It doesn't come with the nice tools really. And so it means that it doesn't encourage you to think in that elegant kind of way. And now if I print B01, B data 01, A1518, that's correct. So I'll just leave that there for now as a reminder of what we've achieved, right? But of course, there are 25 problems. If I solve them all and I put them all in this one file, then because I can't just run a bit of it at a time, I have to run the whole file, then that's going to weigh me down eventually. But anyway, that's just life. So if you've made it this far, well done. I'm going to now see if I can do better than this, right? This is awful code. But it could be a bit complicated. So I'm going to say, I'm going to call it sliding window for a collection. Call it col for collection, and the size is n. And so this is a very general thing, right? So I'm making a comment here, so like a documentation comment. So, and best given by example, I think, e.g., if you have 5, 1, 2, 8, 3, and n equals 3, then you'll get 5, 1, 2, 1, 2, 8, and 2, 8, 3. Okay, that's just showing you what it will do, right? And just to note, the values are yielded, not returned. Okay. Now, I don't necessarily know what that means yet, but hopefully soon. So what we need, right, if we're sliding window is, so, right, say for I, well, n equals length of collection. Now say for I in range, so I'm going up to n, but where do I start? Well, if n was equal to 3, I would start at index 2. So I'm going to start at little n minus 1. And now I'm just going to yield, I'm going to yield a triplet or a pair, a tuple or whatever. Actually, I can't. Okay, I'm going to say, all right, I'll do this in one line. Yield a tuple made up of x's from I minus n plus 1 up to I plus 1. I think that's right. Now I know that's complicated, and that's why we appreciate it when a language gives us these tools out of the box and we don't have to create them ourselves, because if it's complicated, we might make an error. But this is literally all the code for the sliding window, right? So I'm going to now try, I'm going to use my okay, 5, 1, 2, 8, 3, and size 3. Okay, and I'll just X's is not defined because it's collection, not X's. Okay, well that actually worked. 512, 128, 283. Okay, so rather than printing it, I'm going to make an assertion now. Assert. I don't need these brackets, so I can remove them. Oops. And 5, 1, 2, 1, 2, 8, 2, 8, 3. Okay, and if I were to do the same thing with a size of 2, then it should give me 5, 1, 1, 2, 2, 8, 8, 3. And I could put more tests in, but if those two, oops, didn't run anything there. If those two work, yep, that works. Okay, so I've now got a sliding window that I can use, right? And I could go and in fact, now that I've got a sliding window, I'm going to redo problem 1A in a more elegant fashion. Right? So rather than having a count and all of that, I'm going to say for A comma B. Now I will have a count because Python just isn't going to make it easy to make that go away. But for A, B, in sliding window, X is 2. Okay? So it is giving me them 2 at a time. And I just have to say, if A is less than B, then count plus equals 1. Return count. Okay, so this P01A here is equivalent to this one, but it's just a bit nicer, right? It communicates what we want. I haven't tested that it works yet, and I should perhaps put this underneath there, and this underneath here. And I run the file, everything worked. There you go. So this worked first time. Okay, so in the Clojure solution, P01A, we've got the partition, and then we filter it down, and then we count how many are left once we've filtered it down, right? So I could code it like that in Python, and it'd just be a bit ugly. And so even though I'm attracted to the elegance of that, it's it's just not. Oh no, I did just think of a way, right? So yeah, I don't have to get rid of any of these. I can keep them around for comparison, right? The last one that you define will win. Okay, I can now do return the length of for A, B in sliding window X is 2 if A is less than B. That actually should Okay, type generator has no length. Oh, okay. I don't think I can use a count either. Yeah. So Python, as usual, so close yet so far. Well, actually, there's a bit of a hack. If I get the sum, see, I put this 1 here. What this is doing is saying, right, for A, B in sliding window, X is 2. That's so if I just use a bit of highlighting here, okay, so this code that's highlighted here is producing a sequence of pairs, yeah? And then I've got a condition here, which is filtering it down. So I've now got a smaller sequence of pairs. And then for each one of those, I'm just putting the number 1 there. Well, if I add up all the ones, then it gives me how many there were. So I should be able to just count it, but Python doesn't do that. So I'll sum up a bunch of ones instead. Okay, so running that, yep, no problem. Right. So there we go. I got there in the end. So here's like the junior high school way of defining it, and here's the much more sophisticated way of defining it. And it's because it's only really a person who has experience with a nice language like Clojure, even though it's difficult to begin with. It's a really lovely language. It's when you have experience with a language like this and you have experience of solving things in this way that you then take a fresh look at Python and think, oh, I want to solve things more elegantly in Python as well. Okay, and then the second one, right, so I can do better here, P01B x's. Let's try to do the same sort of thing. So I'm going to do it a bit at a time. So for okay, I'm going to say sums equals sum t, or sum, let's call it triplet, for triplet in sliding window x is 3. Okay, now let's just see what we've got here. So these things you sort of read from the inside out. So for triplet in sliding window x is 3, we know that produces a sequence of triplets, right? And then if you get the sum of each triplet, we've now got a sequence of sums. If I changed the surrounding brackets to square brackets, I'd get a list. Okay, so I'll do that, and I will, well, I'll just return sums, and then I will print 01B data of test 01, and then exit so I don't run those assertions down there. Okay, so there's a list of sums, right? Down the bottom. If I just get the triplet instead of the sum, okay, then you can see there's a sequence of triplets, right? And so having the sum, now if I change that to round brackets, then look what happens. It says return, I've returned a generator object. Okay, I don't get to see what's in it. A generator object is like, it's more abstract. It's not a physical list of things. It's a It's a promise to provide those. So what I can do is say for x, or for s in sums, print s. Okay, so no, right, I didn't write it. So there we go. Okay, so that prints each of the sums, right? So anyway, by doing this, I've got a generator of all of the sums, and now what I can do is call P01A, and because I can now pass it into the I can pass it into my earlier function, because that will count how many things are increasing. The answer here should be 5, and I've got an error. Right, okay. Now, surprised at that actually. If I run this again, and by the way, and make it so that we clear the screen each time. Okay, so we're on line 15 apparently. Planning, sliding window. Oh, okay, right. So the sliding window, it can only take like an actual list. It can't take a generated list, because you can't ask for the length of that. Right, fair enough. So for me to do this, for me to make this work, I would need to make the implementation of this more complicated again, and I'm not going to do that now. Right, so there's probably a Python library out there. I'm sure there would be a Python library that has good support for these sequences and sliding windows and that sort of thing. But then I have to then install that library and learn how to use it, whereas in Clojure, the whole language is built for doing exactly that sort of thing. So this is a good place to end it. I have solved both of the problems, and I came really close. I've done a much nicer solution of problem 1A, and I thought I was going to get a nice solution of problem 1B, but I just didn't quite get there, and it's a bit too complicated for me to continue with this now. So anyway, hope you enjoyed that and learned a thing or two, and see you later.